Okie dokie. Here's our equations, tables, and functions lesson. This is our last lesson in our short little unit on functions. So we're going to kind of combine things together, writing their equations, using our function tables, and eventually we'll work up to graphing our results. So go ahead and get your note set up, get your title, your learning target and your standard, and then your I can statement. Your I can statement kind of has two parts. First, can we use an equation to make a function table? And then can we write an equation to model what's going on in a real situation? When you're ready, go ahead and hit play to continue on to the next page. All right. So first we want to see, can we just use our function table and use it to model what's going on in an equation? So we want to use the equation y is equal to x plus 4. And we're going to make our own table of values, our own function table. So nice and simple. Hopefully you can draw a little straighter than I am. We're just going to create ourselves a little function table, just like we've done for other lessons. Okay. We put our x's, that's our inputs, then our y's. Sorry, it's a little harder to draw straight than I thought it was. And in the middle, we're going to do the actual work. In this case, it's going to be x plus 4. So to make our function table, we want at least 4 values to go into our function table. So you can kind of choose which ones to work with. Usually I like to just start with 0, 1, 2, and 3. Or if you think it'll work better, you can always just do 1, 2, 3, and 4. But let's start with these. We're going to plug each one in for x and do the problem. 0 plus 4 is 4. I plug in my 1 in place of x, I get 5. Plug in a 2, and plug in my 3. Okay, that's how I make a table of values. Basically, I choose some inputs, plug them in, and get the outputs that go with it. Then it says let's turn them into coordinates that we could go back and graph. Remember, coordinates are going to be x and a y in a pair. So for instance here, I have the coordinates 0 and 4. So those are my coordinates. Then I have 1 and 5. So I'm just taking my x and y pairs, the inputs and the outputs, and turning them into coordinates that tomorrow we'll actually go ahead and graph. I don't want to make you draw out an actual graph and have to set all that stuff up, so we'll go without for today. Okay? So let's try another one. Y is equal to 2x plus 0.5. So let's see if I can draw a little straighter this time. Well, it doesn't look like much straighter, but I'm trying. You can be setting yours up as well. We want our x, our y, and then our actual work. 2x plus 0.5. So we'll plug in our 0, our 1, our 2, and our 3. Okay. Basically, we're just going to plug these in and see what we get. So I put in 0 for x. So 2 times 0 plus 0.5. Well, 2 times 0 is 0, plus 0.5 is 0.5. Think about kind of like money. You're just adding 50 cents on. Plug in a 1. 2 times 1 is 2, plus 0.5 is 2.5. Plug in a 2, so 2 times 2 plus 0.5. 2 times 2 is 4, plus 0.5 is 4.5. And plug in a 3. 3 times 2 is 6, plus 0.5 is 6.5. So that's how we create a table of values, our function table, based off our equation. We choose our inputs, plug them in, and then see what we get for our outputs. So now let's see if we can do the opposite. Now let's see if we can use a function table to help us find our equation. So here's our problem. The Drama Cub is holding a bake sale. They are charging $5 for each pie they sell. Write an equation to find the total amount, T, earned for selling P pies. So it's basically $5 a pie. So we want to figure out our equation, so we start with our function table. We want to kind of study what happens for each number of pie that I sell, what happens to my total? So let's think of it as, what happens if I sold one pie? Well, it's $5 for each pie, so my total would be $5. What if I sold two pies? Well, they're $5 each, so 2 times 5 gives me 10. What if I sold three pies? Well, $5 each, 3 pies, 3 times 5 is 15. Okay? Now you kind of notice that every time I make a purchase, I'm just taking the number of pies, P, times $5. So what am I doing to P? I'm multiplying it times 5. $5 times the number of pies, and that gives me my total. So sometimes by building that function table, it lets us know what's going on in the problem. That helps us figure out what is our equation. What are we actually doing to find our answer? Well, we're taking the number of pies, and we're multiplying times 5 each time. So how about this one? It says a company charges $50 per month for satellite television service plus an additional $5 for each movie. We want to know how much is it going to cost each month depending on how many movies I buy. How could I calculate that, or how could I find an equation to make that nice and easy? Okay, so let's do M for months and C for cost. Or sorry, not M for months, M for movies. So based on the number of movies I buy, or I rent from my cable service, what is my cost going to be? So let's start with 0. What if I didn't rent any movies? How much would my cost be? Well, it says it charges you $50 a month for the service, even without the movies. So $50. What if I ordered one movie? Well, I still have to pay the $50, but then they're also going to add on $5 for the movie. So that gives me a total of $55. What if I ordered two movies? Well, I still got to pay $50, and now I got to pay $5 per movie. So 2 movies, that's $10, plus the 50 gives me $60. So stop and think, how was I calculating that? Well, I was doing 2 times the number of movies plus $50. Oh, let me fix that for us. I was doing the number of movies, multiplying it times $5 plus the extra $50. Okay? So I take the number of movies times $5 plus the extra $50 I have to pay anyway. And that helps me calculate my total. So building that function table kind of lets you see, okay, what am I doing to actually calculate these amounts? And then I can use that to find my equation. This way I could plug in any number of movies and very quickly figure out what is my total for the month. So let's do one last one. If you think you've got the hang of this, try it on your own. If not, let's do this one together. It says a fare charges an admission fee of $8 and each ride's cost is an additional $2. Sorry, I should have a little apostrophe there. The ride's cost. So I just want to know, how could I write an equation to help me calculate how much is it going to cost based on how many rides I want to go on? So let's go R for rides and T for total. And this time we'll make our function table go horizontally, just because we want to be able to do both. Okay. And we just want to know, based on the number of rides that we go on, how much is it going to cost? Well, what if I go on 0 rides? Well, it's kind of a boring trip to the amusement park or to the fair, but they're still going to charge me that $8 just to get in. So maybe you're just going to watch your friends. What if I go on 1 ride? Well, let's do that over here. It's going to cost me $8 to get in plus $2 for the ride. So that's a total of $10 for the 1 ride. What if I do 2 rides? Well, it's going to cost me $8 plus $4 for the ride. Basically, 2 rides times $2 a piece. So that's a total of $12. So what about 3? Well, I'm going to do 3 rides times $2 but I always have that extra 8 that I'm being charged. So 3 times 2 is 6, plus 8 is 14. Okay? We'll leave out this last row here because I think we have enough to figure out what's going on. To calculate our total, T, we're taking our $8 plus, what did we do each time? Here we did 2 times 1 ride. Here we did 2 times 2 rides. Here we did 3 times 2 rides, or 3 rides times $2. So we're taking the number of rides, R, and we're multiplying it times the cost, $2. So no matter how many rides I want, I just do 2 times the number of rides plus the $8 admission fee to get my total. That's how I get my equation.